That's a really good question. So to make current conventional geothermal work, you first must find pockets of Earth with just the right natural water, just the right depth, and just the right rocks. And when you do that, you can heat or cool a few buildings, which is impactful, but it's really not significant enough to change the world's power needs. Deep Power is developing a breakthrough geothermal drilling technology to access the Earth's unlimited source of clean energy. The Earth's molten core is as hot as the sun, which is evidenced by the eruption of volcanoes and geysers such as Old Faithful in Yellowstone's National Park. Did you know that if you could just harness 0.1% of that heat energy, we could power humanity for 2 million years? The problem is current state-of-the-art drilling technology cannot drill deep enough to really make geothermal cost-effective at a global scale. But Deep Power is developing a suite of breakthrough drilling technologies to boldly go where no man has gone before. The deeper we go, the more energy we can unleash. Unlike large area solar and wind farms, if you could just drill a 9-inch hole 5 miles deep, you could produce the same amount of energy as 320 acres of solar panels. By plugging into this power deep within the Earth, we really aim to provide direct access to an unlimited source of constant, clean energy anywhere in the world. Deep Power is developing that breakthrough geothermal drilling technology to access Earth's unlimited source of clean energy. So super hot rock geothermal energy is accessible just about anywhere on the Earth. What's amazing is that nearly 50% of the world's population can access super hot rock without going deeper than 6.2 miles. Drilling down to 12.4 miles virtually guarantees that 95% of the world's population can have access to unlimited clean energy. This is huge. We get asked this question all the time. So geothermal, especially super hot rocks, really checks all of the boxes as the ultimate clean source of energy. Perhaps the most dramatic reason why may be how little land geothermal power plant uses. Unlike large area solar and wind farms, 2 9-inch geothermal wells drilled 5 miles deep can produce the same amount of power as 320 acres of solar panels. With geothermal, we can reclaim our land for our buildings, parks, and forestry and have way less impact to our environment. While super hot rock is the holy grail of geothermal energy, hot rock can be cost effective at an average depth of 4.3 miles and a minimum temperature of 150 degrees Celsius. According to a U.S. Department of Energy GeoVision study, this has the capacity to produce 5,157 gigawatts, or 5 times the United States' current utility scale installed capacity, which includes coal, natural gas, nuclear, and renewables. However, that cost still may be too high to bear for many areas. Going to super hot rock solves everything. The U.S. Energy Information Administration estimates that super hot rock geothermal electricity can be produced for as low as anywhere between $20 to $35 a megawatt hour, compared to $85 a megawatt hour for solar, $96 megawatt hour for advanced nuclear power. As a point of reference, the wholesale rate of electricity in California in 2019 was $74 a megawatt hour. The research and development of the Deep Power platform is led by Professor Saeed Salehi at the University of Oklahoma through a sponsored research program funded by Deep Power. Dr. Salehi, Associate Professor of the Mewbourne Professorship in Petroleum Engineering, has an extensive background in geological engineering. He previously worked as a drilling and well engineer in the oil and gas industry and has more than 10 years of academic experience teaching and delivering university and industry customized courses.